Hi, thanks for joining me today. I've got an interesting infinite series problem. We want to compute the sum from n equals 1 to infinity of pi of n over n squared, where pi is just a bijection between the natural numbers. So in other words, pi is just a permutation of the natural numbers. If you want to have a go at evaluating this sum, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so I'm going to prove that this sum here actually diverges regardless of what the bijection pi is. And the way I'm going to do that is by considering the tail of the sum. So what do I mean by that? I simply mean the sum from n equaling n plus 1 to infinity, where n is an arbitrary positive integer of pi of n divided by n squared. Because if this guy here converged, then that would mean that this tail here would tend to 0 as capital N tends to infinity. So I'm going to show that it's impossible for this tail to tend to 0. And the way I'm going to do that is by considering this, as I say. And notice, because pi is a bijection from the natural numbers to the natural numbers, in particular is positive, n squared is positive, so all of these terms here are nice and positive. Okay, well this thing here is definitely going to be bigger than or equal to the sum from n equals n plus 1 to 3n of the exact same thing. So I'm just only looking up to the first 3n terms. Okay, and now what do I know about this? Well, I can firstly take out this n squared because I'm doing bigger than or equal to, and this n squared I can take out by just taking the biggest number possible. So this is bigger than or equal to 3n squared of the sum from n equals n plus 1 to 3n of pi of n. And this thing here is just 1 over 9n squared. But what is the sum from n equals n plus 1 to 3n of pi of n? Well, again, we're going to bound it below. And, well, how can we do that? Well, we know that pi is a bijection from the natural numbers to the natural numbers. So, in particular, there are 2n terms in this summation, and they're all different positive integers. And because we've got 2n terms, at least n of them have to be bigger than n. Because, well, there are 2n positive integers, and they're all distinct, so there have to be at least n of them which are strictly bigger than n. So this thing here is strictly bigger than 1 over 3n squared, which is 1 over 9n squared, multiplied by 2n, sorry, not 2n, just n, times n, because there are at least n terms here which are bigger than n. And then, of course, we're going to have some other positive stuff as well, but that's only going to help to make this bigger. So we've got that this is bigger than 1 over 9n squared times n squared, which is equal to 1 over 9. So this thing here, the sum from n equals n plus 1 to infinity of pi n over n squared, is always at least 1 over 9, and therefore it cannot tend to 0 as big N tends to infinity, and therefore our original sum here diverges. And that is our proof. I hope you have enjoyed this quick infinite series video. If you are new to the channel, please do consider subscribing to get notified when I upload more fun maths videos like this. There's currently about 85% of people who watch these videos who aren't subscribed, so I'd really appreciate it. If you are still watching this, hopefully it means you have enjoyed this video. Do give it a like, do subscribe if you haven't already. I'm going to stop waffling now. Thank you for watching. I'll catch you in the next one. Have a great day.